Right, hello ladies and gentlemen and welcome to today's video. And today we're going to be taking a look at a couple of PlayStations. We're probably going to split them down into individual pieces, to be honest with you, because it'd end up quite a long video otherwise. But essentially we have three PS2s, PS4s, which have been sent up by a valued, I believe he's a subscriber to the channel, and he's also messaged me on Twitter a few times, called Andrew South. Seems a really nice guy. And has a couple of PS4s that he's been having some trouble with. So one's been sent away and has some HDMI issues, and it's come back and it's blodding and all sorts of bits and pieces. There's another one in there which had an issue with its power supply and had the Watchdog IC swapped out, which we do cover on this channel. If I remember, I'll pop a link to that particular video in the description. But essentially what that does is it causes the machine to power off during certain procedures that it performs. That was replaced and seemingly all was okay until his kitten knocked the machine off and it fell onto its HDMI port, and now it just gives a load of green lines and grey screens and everything else. So we'll take a look at that. And then there's another one here which is just for parts and was blood apparently. So don't know if there'll be anything we can do with that, but we'll take a look and we'll see what sort of state the machines are in. So one is a white one, which is this one here. So this one has a note on the front of it, and this says, this is the one that had the DMP015, so the Watchdog IC within the power supply changed. It says, but kitten knocked it off desk onto the HDMI, white screen or green lines, with question mark. So that's probably the one we're going to look at in this video. And then we also have this one, which is a black one with it's had a rather nice sort of carbon fibre effect white skin on it, quite like that. And this one says, had HDMI fault, was sent away for repair, but no output and no light. It's constantly pulsing, so I presume that's constantly pulsing blue light of death. It annoys me, right? I tell you now, right? And we've had this rant before, so I'll try and keep it short. But this does annoy me, because at the end of the day, you send things away to have them repaired, and they come back with, a blue light of death, and it's like, well, why has it got a blue light of death? I appreciate things can happen in shipping. I've actually had it happen to me before now, but we took it back, we fixed it, we sent it back, absolutely fine, but yeah, in this instance, the whole story, which was relayed to me by Twitter, by DM, it doesn't sound like it's shipping damage. It sounds like there's been some very shifty things going on. Apparently there's some marks around the front USB ports which look a little bit suspect, which Andrew swears weren't there when he sent the machine in. So maybe it's been switched, maybe it's been swapped. Yeah, you know what I mean? This is the sort of thing you've got to be really careful of. And like I said, it pisses me off. You don't have to have any formal qualifications or training or certification to do this. Anybody can rent a shop unit for a couple of £100, put a sign in the window saying, games console repairs, and you don't know whether they know what they're doing or not. So let's have a look at these then. So the first one we're going to have a look at today is DNP015 replaced. Kitten's knocked it off the desk, and now the HDMI doesn't work. So we'll get cracking on that. So we'll plug it into the TV, and we'll see what we get. Right, okay, ladies and gentlemen, so we tried something a little bit different there, but it didn't work out quite so well. So, essentially what we've got here is the white light of death, because we have a white light on our PlayStation, but if we have a look at the screen up there, there's no output at all. Nothing whatsoever. So, it's actually a little bit unfortunate, because what I tried to do was actually get a bit of video capture going for you, and actually tried to capture the video from the PlayStation as it was here, but unfortunately the capture box I've got is a bit shit, and yeah, it didn't work out quite so well. But so I'll tell you what, let's try it now. So we've got our USB in there, right? So we've got a signal synced up. So let's try this then. So let's try and record something to it. Okay, so there we go. So apparently now that's capturing video. So you should see now what's on that display. So there's black screen, there's no output at all. Okay, so we can see there's a white light on the console, but there is a black screen on the actual monitor. There's no output there. So let's just fiddle the lead and see if we can get anything at all. Anything whatsoever. It sort of pulses the backlight in and out, but you probably won't be able to see that. So there's a few like green dots and things and lines and stuff going around the display as we wiggle the lead. I don't know if those will show up on the capture, maybe they will. But yeah, so that's as we move the lead up and down and in and out. So what we'll do is we will try and capture that. Hopefully that's going to have captured it anyway. And then what we'll do, ladies and gentlemen, is we will take a look at the port, because it looks like the port's damaged, because as I say, once you wiggle the lead in there, it actually, you know, it glitches about on the display. So hopefully the capture might have just captured that for you so you can see properly what it's doing. So what we'll do is we'll get it stripped down, we'll get it in bits, we'll have a look on the table. Well, the first thing to do, to be honest, is replace the port and see if we get video from there. It's hardly surprising if the port is destroyed, because of course it's been it's landed fairly heavily on it by the sounds of things. So we'll replace the port and we'll see if we get any output from there. So join me in a sec, ladies and gentlemen, and we'll see what we get. Hello there, ladies and gentlemen, and welcome back. And we've got our PlayStation board out of the PlayStation. Now then, the thing on your screen right about now is from our video capture device. It's from our microscope camera. Now then, can anybody hazard a guess as to what that is? Anybody at all? Anybody? No? Not a clue? No, well neither have I, because oh, I can't believe this. Right, I took this board out of this machine. Okay, I took this board out of this machine, and on the underside, and I'll try and get this for you. It's obviously it's had a port replacement before. Okay, not the best quality port replacement in the world, if I'm being honest. Where's that? That looks like somewhere close to where we want to be. Is it? So yeah, it's not the best quality port replacement in the world, because I'm just trying to see if we can get a little bit better picture. So yeah, it's not the best quality port replacement in the entire world. I mean, they've left a lot of sort of crappy old flux residue all over the board, as you can tell, and yeah, the joints are a little bit scruffy, not particularly great. As you can see, that's the underside of the port. The port itself actually has some flux residue inside it, which is never great. And then if we flip it over, you can sort of see the same again there on top of the port, and the actual board itself is indeed covered in flux residue. You can see there's a bit of a scratch across it there, but that shouldn't affect it too badly. Yeah, it just looks a little bit, you know, it's just a little bit nasty, really. The actual pins themselves are there. That gloopy stuff down the back, I think, is flux. You know, but there's no bridges or shorts in there. So by the looks of it, this probably, well, it probably worked. I'm saying it probably worked. But yeah. But as for the thing on top, the thing we've just been looking at there, okay, if we go back a little bit, and then go back a little bit further, and here's the RAM. Anybody has a guess of what the hell that thing was earlier? Ooh, APU. Yeah. Now then, to anybody with half an eyeball and who knows anything about these things, will know that that thing there is not supposed to be there. That, ladies and gentlemen, is rather worrying, because that looks like a custom designed, because it fits perfectly over the top of the central die. That, ladies and gentlemen, looks like a shim. That looks to me like somebody has purposely designed and built that and made it to fit. Well, I'll tell you what we do with things like that. We don't have them on our boards. We don't have those on our boards. No, that doesn't work for me. Sorry, but that is going in the bin, because that is going to cause more damage than good. And do you know what? Right, if this thing pulses blood when it's finished, then as far as I'm concerned, you know, it ain't fit for use anyway. If the only way this machine works is with that horrible thing stuck on top of it, then quite frankly it's buggered. pending reball. But yeah, so there's no way am I ever sending a machine back out with that on. It ain't happening. You know, I mean that's ridiculous. That is ridiculous right there. You know, and do you know what? The thing is, this thing probably worked absolutely fine without it. You know, but all that does is just it warps the board, it warps the die. That's, you know, it's probably sold as a preventative measure. Funnily enough, it's probably been touted as, oh, you know, put this in and, you know, it's copper, it will transfer further heat away from the APU, it'll safeguard your machine from the blue light of death. No, do you know what? It's probably going to cause it. It's probably going to friggin' worsen it. It's going to speed that up. It ain't going to solve anything. Right, so we will give that APU a good clean out. We'll change it out. We'll put some nice Arctic MX4 on there. And we'll make sure it's all nice and properly cleaned off before that goes back. So, yeah. So we will do that. So as you can see now, for those of you who don't know, there you go. That's what you should see. You see that nice laser etched text on the top of it there? Yep, that's exactly what you should see. If you don't see that and you see a big copper slab of crap stuck to the top of it, for God's sake, take it off before you completely ruin your board. If you have one of those installed on your machine because somebody sold it to you as a nice preventative measure, then for God's sake, do yourself a favour and take it off now. So, anyway, that's that out of the way. So that's the first job. I hate seeing things like that. I really do. It's almost, well, it's the same sort of thing as the bolt trick on the old 360s. It's just as bad. So, anyway, that's that done. That's that bit of a rant. So we've had a look around the board, and obviously that port don't look great, and the job itself don't look great, but yeah, it probably worked. So what we're going to do is we're going to take that off. So we're just going to get rid of the microscope camera for now. And I'm going to stop my capture. So we don't fill the card up. Okay, so what I'm going to do now is we're going to get some hot air on this. Oh, bloody hell. We're going to get some hot... I've just covered my phone in crap. Right, so I'm just going to get some hot air on this particular board. So that's our next job. So I'm just going to face that down towards the board. So, yeah, for those of you who don't know, actually, a few, well, probably about a month or so ago now, my old LG G4, which I used to capture video on this channel, actually died a rather spectacular death, and I've had to replace it. Now, the phone I've replaced it with is something called the Vernier Mars. It's a Chinese jobby, but it's a fantastic piece of kit, to be honest with you. They've actually got one coming up called... it's a Vernier Apollo. They've got the Apollo Lite at the moment, but the Vernier Apollo is the one that's coming out. That's got... hexacore processors, VR ready, and all sorts of stuff. And it's about 200 quid actually if you have a look. So that's probably the one to go for if you fancy a new phone and you don't want to spend a fortune on it. But yeah, I mean, this thing is great. But I don't think the camera's the best in the world, so we'll see how we get on with it. We might just have to go and buy a new camera at some point. Can't afford it yet though. But yeah, so we're just going to try and zoom this in a tiny bit. So we'll see how we get on anyway. So we're going to put some fume extraction on. Ow. Okay, so fume extraction is on. So I'm going to try and, well, I'm trying to do this bloody sideways because I'm sat opposite the camera. So I'm trying not to knock the camera. I'm going to try not getting the camera's way, and I'm going to try and remove this part. So what's the... It can't possibly go wrong, this, can it? So, anyway, what we're going to do is going to apply some flux. Now then, it looks like it's got plenty on it anyway, to be perfectly honest, but... yeah. So, that's all now fluxed up. So, what we're going to do is we're just going to change the tip on my soldering iron. Soldering iron's actually plugged in, just bear with me a sec. So that's the other problem, of course, is that for those of you who don't know as well, is this is my mate's old home office. He's kindly let me do these videos and give me a bit more room, but I've nowhere near enough plug sockets. So The situation's a little bit better, but it's not perfect by any stretch of the imagination. So anyway, we've just plugged that in now, so that's there. So we've got some fume extraction on. We've fluxed up the ports there. So the first job, actually, if you've never, if you're dealing with a machine that's actually a bit virginized and has never been fiddled with before, then you're going to want to put some leaded solder over the tops of the ground points here. So there's 4. Unfortunately, they've been merged together on here, which isn't going to hurt anything because they're just ground. But it just makes your work a little bit more professional if you do them right. My soldering iron says it's up to temperature, but it doesn't seem to be melting anything. So I think it's talking rubbish. Let's try that again. Okay, so it still says it's up to temperature, and it's actually got nothing plugged in. I think we may have broken it. Hang on. So we're going to add a tiny little bit of leaded solder onto these. Now then, it looks like it's probably already got... Yeah, it does. So we're just going to work that back and forth, and the reason for that is because the biggest part of this port is going to be held in by these 4 ground pins, okay? So these location holes here. So because they go through a big ground plane, most of the heat that you apply to the port is actually going to be sucked away by the ground plane. So it's going to act as a big heat sink. So by running a bit of leaded solder into there does one or two things. One, these holes are fairly deep and have lots of lead-free solder in by default, which isn't very good at taking and absorbing heat. It takes a lot of heat to actually get it to melt. By putting some leaded in there, it just kind of, for want of a better word, dilutes it down. So you don't have to work it quite so hard. And 2, because you can work a bit of heat into the board with the iron there, with a big tip, it actually helps soak the heat into the board slightly before you start, which again just makes it easier. You don't have to work it as hard with the hot air, all of which is beneficial. So we're just going to work this back and forth, back and forth, back and forth until we can loosen this port. So because it's been applied with what seems to be leaded solder, that did melt incredibly easily. This probably won't take an awful lot of getting out of here. There you go. Told you, didn't I? So okay, so that's the old port there. Don't look particularly brilliant. So we'll get rid of that. Now then, the only problem that you might have if you come across one of these where somebody's already replaced the port, depending on how they do it, sometimes the holes, the locating holes for the new port actually get knocked out of shape. So by default they're rectangular with curved edges, so they're not oval, but they're like oblong shape, if you like. So, but by the time, depending on the method that whoever's replaced the port initially is used, sometimes they go out of shape, so they get knocked out into sort of like more round or sort of like oval shape, and that can make locating the port a little bit more difficult second time round. So let's just have a butcher's here. So you can see there that the one that's top left there, so that one there, you can see is more circular now, and it's certainly a lot wider. The one on the top right is out of shape too. The one bottom left doesn't look too bad. The one bottom right's got a bit of solder in it. It looks a little bit wider than it might normally be, but not too bad. So hopefully we can use the fronts to relocate this port a little bit more accurately. So we have a nice shiny new port there, so that's all well and good. So that's ready to go in. Now then, the thing is that by default new ports sit slightly off from where the pads actually are located on the board, so that can make locating them a little bit hard, because you have where the pads are, which you need to solder to, but the legs sort of sit in between, so you've got to adjust the port ever so slightly. So what you need to do is get your port so it's nice and straight. So I'll just try and zoom this out a little bit so you can see a little bit clearer detail. So all you need to do is you need to get them, and you need to get like a pair of needle nose pliers or something like that, and just move them out, say around a leg's width to the right hand side. So just bend it out by say half a mil or so. So just so your port legs have got a slight lean on them. Nothing too major. But sort of like the width of the leg. So just move it to the right, the width of the leg. Both on both sides, left and right. So your port legs have a slight lean to them. You don't need to do, you don't need to do a lot on them. So I don't know if you'll really properly appreciate that there, but because it's kind of hard to. We're talking about such small margins that it's actually hard to really demonstrate it. But maybe you can see there, certainly on the right. If you're looking at the port straight on, you can see the legs are ever so slightly bent to the right hand side on both the left and right sides of the port, on all four legs. Okay? Once you've done that, it should line up a lot better for you. So what we're going to do is we're just going to take our board. Okay, yeah, they are bent quite. Yeah, they are quite badly out of shape, which is unfortunate. Yeah, that could make putting this back quite interesting. So what we're going to do is we're just going to clean up the board now a little bit. So we're going to get some desolder braid. Already looks to be plenty of flux on there from the last time this was replaced. So I just want to know what sort of state these pins are in. So we are just going to apply a little bit more to it, because sometimes when you put the soldering iron on there and there's old flux residue, sometimes it will reactivate. In this particular instance, so let's have a look then. So it looks like we're missing a pin, which was probably done before. Oh yeah. So when it's actually fallen onto the right, so we've actually got some pin damage, which is hardly surprising if it's had a bit of a whack, which is probably why it's not been working as well as it might have otherwise done. So let's just take a look under the microscope and we'll see what we've got. But this is probably why it didn't look so cool. So the actual impact with it landing on the impact of the machine landing on its port has actually damaged the HDMI header. So what we're going to do is we're going to fill these holes back with solder. Okay. So I'm going to fill these holes back up. Could take a bit of doing. So just going to work the solder into the holes. Just try and fill them back up a little bit. Kind of getting there. That massive one at the back I don't think it's going to fill too well. But the others seem to be filling okay. Yeah, that one at the back I don't think is going to play, but the front three look okay, so we'll try that again. So, just going to support the board up, and we're going to get our port back in our mould guts. I'm going to get our hot air again. So you'll notice maybe there that you can see the solder's actually balled up above the surface of the board. So once we apply the heat and it melts, what's actually going to happen is that solder that was sat above the surface of the board is actually going to melt and sink into the hole. And once it does that, as has happened on the left hand side there now, as you can hopefully see there, and it's now happened on the other. So we're just going to offer our port up, drop it into the hole, just going to hold it nice and square to the board, leave it a few seconds, and we can see there now that our port is nicely into the holes. So that is what we were looking for there originally. But as I say, on previously reworked boards or damaged boards, it can be a bit awkward to do. And then we're just hoping that our pre-alignment of those ground pins is actually going to help that port to have settled into the appropriate place. And I hope that we're not too badly out of shape. This is actually going to pull the port back out of line again, because that's always the risk again, you know, with a misshapen board or a damaged board, is that it doesn't seat quite so well. So that's always the risk, but you can mitigate that risk. So we're just going to move the fume extraction out of the way, and we're just going to take a look at the port alignment. Just make sure it's sat roughly where we want it to be. Right, so let's have a look at that now then. Video stream's just cut onto the capture hardware, so I've just had to come back and redo this. But as you can see there now, this is our port. Now we've offered it back into the holes. So if we have a look underneath, you can see that the excess solder in the holes comes out as you push the port through. So we can clean that up afterwards, we're not worried about that. But as you can see, those pins now line up onto those pads beautifully. And that's the benefit of just filling those holes back in and just slightly bending those locating pins back to the right hand side. So as you can see, that's absolutely perfect. So what we're going to do now is we're just going to solder those into place properly. So you've got the pins there, of course, which don't actually have any pads underneath them anymore. So not too worried about those. So we're just going to apply some flux to the back of this port, and you can be quite, you know, generous with it, because we're just going to clean it off afterwards anyway. So we want a fairly thin tip on our iron. So I'm just going to change our soldering iron tip back to the smaller one. Okay. So what we're going to do is just going to tin the end of the iron, and bearing in mind we tinned the pads before we started. Just going to wait for my soldering iron to decide it's going to work. So okay, so we've just tinned the end of the iron there now, so that's nice and shiny. We tinned the pads before we started, remember. So all we've got to do now is actually walk back along here. So we're just going to go across each pin and initially just press down onto it. So we've got flux on there, remember? And what that flux will do is it just encourages any solder on the pad to run up onto the leg of the HDMI port. And you'll see they go nice and shiny. and then just go and touch the base of the leg and the pad, just to make sure that any solder and the pad there just nicely combine. So it just causes the solder to actually run up the leg of the thing there. So we've got those nicely in position now. So I'm just going to give this a rub off with some more IPA, if I can find my thingy. What have I done with it? Do you know? I found the brush on the floor. Oh, I've run it over. Okay, I found it. So, just going to pop a dab of IPA into there. I'm just going to go over it with the bristles. So this is the problem with drop damage, you see, because it can quite easily knacker quite a lot of the board, which is never a good thing. If it lands on the HDMI port, as you can see here, it can cause a bit of a mess. So we can see then that some of the pins actually have like a little dark, shadow around them. That's the ones with no pad underneath. So we can see there, of course, we have that one there. Pin 2, pin 5, pin 9. Oh no, sorry, I'm going back to front. We've got that one there. Find it. So we've got that one there. That's pin 3. Sorry. So pin 3. Pin 4 is okay. Pin 5. Pin 6, 7, 8, 9, 10 are good. Pin 11 has no pad. Pin 12, 13 has no pad. Pin 14 is good. Pin 15 has no pad. 16 is fine. 17 is fine. 18 has no pad. And 19. So we were saying before, that one's going to need so pin 3, which is that one there, is going to need a link wire. That one's ground, we're not worried. That one's ground, we're not worried. That one there, pin 15, is going to need a wire. And pin 18 there is going to need a wire too. So we're just going to move the scope camera back out. Well, actually, no, we're not. We're going to move the phone camera back in. So we can see the port there. So what we're going to do is we're going to run some link wires now out across to where we need them to be. So I'm just going to check pin 15 actually, because I can't remember whether pin 15 is ground or whether it's actually a signal. I seem to suspect, if I remember rightly, it was signal and he's going to need a wire. But obviously I can check that from here. Indeed it is. It goes to the little 2K resistor behind that protection diode on the right hand side of the port. So we are going to need to run a wire there, and we're going to need to run 2 others. So we're going to need 3 wires in total on this board. So to run a link wire, what we do is we get this stuff called magnet wire. There we go, magnet wire. Really tiny little enamelled copper strands. It looks like bare wire, but trust me, it isn't. So what we're going to do is we're just going to tin the end of some of this stuff. Which strips the enamel coating back. So if in doubt, I've actually got a video on the channel which details this procedure quite nicely. So if I remember, I'll link that into the annotations below, or the descriptions even. So feel free to go check that out. That'll tell you how to run link wires and what you need to know, what equipment you need, what wire you need, and everything else. Okay. So the first one we're going to do is pin 18. So what we're going to do is we're going to get hold of that wire, a pair of tweezers. We're going to offer that up to the port. Hopefully the capture's still running, because I can't see the box from here. And there we go, and that's about as difficult as it gets. So it's a lot easier with a big microscope, obviously. Okay, so what that does, that runs down to this little diode here on this side. So we're just going to link into there. So the way we do that is I'm going to get another pair of tweezers. It still looks to be running, which is cool. So we're going to get another pair of tweezers. And what we want to do is we want to make sure that this wire is as flat to the board as possible. So we're going to hold it flat, and then roughly where we want it to bend, we're going to hold it roughly where we want it to bend, which is about there. Make sure that's nice and straight. Bend that roughly into position. So roughly around there. Okay. And then what we're going to do is we're going to get the iron. And we're just going to mark it roughly where we want that to be. So we're just going to push it down with the iron. So that's the other problem, of course, you've got as well. Sometimes, in as much as the iron will actually carry the heat through, because this is just copper wire and it's really thin stuff, so it transfers heat very well. And what can actually happen is that the wire transfers the heat too well. And what you can actually end up with is the wire actually coming off the chip, particularly on a short link wire like this one, because it's not very, it's not a very long wire, is it? So the shorter link wires are always the hardest ones to run. Always seem to be the most awkward. But anyway, so what we're going to do there now is we've just got the wire tinned back up there. So I'm just going to try and get a hold of it. Because it's so short, this is going to be very, very awkward. But the shorter ones are always the pain in the arse. It's kind of like ballet. You've got to got to try and get it somewhere close. Right, so there we go. So we've got that there now. And what I'm going to do is I'm just going to try and do this wrong-handed, which can only go well, can't it? Just try and bend that wire back to where we want it to be, which is there. And just hook it onto that. Trying to do this through the viewfinder, which is not going to make this the easiest thing in the world to do, but so we can see there now, look, that our link wire is attached to the back side of that diode. Don't worry about that, that's going to go nowhere. It's actually nowhere near that. As you can see, it's quite clear of it, but even if it did move, the insulation's still there. It's not going to go anywhere near shorting that out. So it's nice and solid there. It's nice and solid there. So that's our first link wire run, which is cool. So we're going to do the other two, and I'm probably going to cut this, and then we'll show you what's happened when they're all done, because it's a pain in the arse trying to do this down the viewfinder with the camera, because I'm having to sort of twist myself and try and do it sideways, which, you know, this job's hard enough as it is. So join me in a sec, boys and girls, and we'll cut it back in when we've got all the link wires on, and then we'll finish up. So join me in a sec. Alright, okay then, ladies and gentlemen, so as you can see there now, we have all three of our link wires run. So let's just show you where they go. So you can see there the pin on the left hand side there, pin 18, goes to the right hand side of that diode. And then we've got pin 15, which is the one in the middle if you like. That goes right around to that little 2K resistor on the right hand side of the port there. On the bottom of the two green ones you can see, or the top of the two green ones as you can see on the picture. And then we have the one on the right hand side, which is pin 3, which goes to that second via line there, as you can see. And then that goes through to the bottom of the board to the HDMI encoder IC. And we've given each of those three wires a good wiggle. They're all nice and flat to the board, as you can see. You know, you can push them around and prod them and poke them, and you know, they're all nice and secure there. You know, they're not going anywhere at all. So that's all good. So we've put a bit of IPA on there and just cleaned over the surface. So that's looking pretty nice now. So all that's left to do now is finish off. So what we need to do to finish off is we need some conformal overcoat pen on there. And what the conformal overcoat pen does is it just secures our wires and makes sure they don't go anywhere. So all you do is you get a dab of this stuff over the top, and I'm just going to apply this. I'll tell you what, if we can get the other camera in, we can probably apply it for you. So let's just see if we can do that. Just bear with me a sec while we get this set up. Okay, so we've got that set up there now. So you can see there, hopefully, where the lines are. So this pen essentially just dabs over the top. So it works. There's a couple of advantages to behind using this pen, and that is one. It's essentially, well, it's conformal coating. So what it actually does is it ensures, I mean, we've got a nice enamel coating on the outside edge of that anyway. So, you know, it's not actually going to short out, but it just gives that extra layer of protection. And secondly, you know, it just bonds these, it's like an epoxy as well, so it bonds these link wires down to the board quite nicely to ensure that they're not actually going to go anywhere. And two, you know, well, three, it makes things look nice and professional. And you know, it's just one of those nice things that I like to make sure I do. You know, plus it just, when it's covered and it's all set and hardened, it's just another layer of protection to make sure that, you know, the wires aren't going to go anywhere and that they're going to stick to the board, and that plugging in and out with the HDMI lead isn't actually going to loosen it. And isn't actually going to allow our wires to stress and fracture. So as you can see there, that's all looking nice now. So we'll pop this back under the the microscope camera, just so you can see it close up. And that's it, ladies and gentlemen. So you'll see there as well, you've noticed, or hopefully you've noticed, what we haven't actually done is we haven't actually allowed any of those link wires to run across each other. So you can notice, you know, they run alongside, but they don't actually cross, they don't jump over each other at any point at all. And the reason for that is to make sure that what we don't end up with is crosstalk and interference, because at the end of the day, you know, these signal lines are necessary for us to actually get a picture, you know, and a nice picture of that. We don't want any snow, we don't want any artifacting, we don't want any, you know, funny dots and white dashes scattering all over the display. You know, we don't want any of that. So what this ensures is, you know, everything runs away from each other. You know, there's no crosstalk, there's no interference, and we get a nice clear picture on our TV screen. So all we've got to hope now, of course, is because one, we have no idea if this worked in the first place. Two, we know it went away for a HDMI replacement and it came back, and you know, obviously the kitten knocked it off the TV stand or the table or wherever it was and actually caused it to mess up again. But so I would presume from that, I'm sort of reading from that this would have worked and was working again. But I don't know that. So let's hope that the issue actually wasn't an encoder IC, or even worse, you know, if it was switched on at the time, then let's hope it hasn't blown the encoder IC, because that's just going to be more work. So we're just going to take this now, we're going to pop this back in the chassis, and we're going to give it a test, and hopefully we're going to get a working PS4. So bear with me, boys and girls, and I will see you in a sec. Right, okay, ladies and gentlemen, so we've partially reassembled the PlayStation. And we're just going to take a look now just to see if this now behaves. So, what we're going to do is, I'm going to power the machine on. Okay, and just take the video up there, and as you can see, we get nice display out there. So I think you probably can't see too well for the light, actually. Let me try and block the light off a little bit, maybe. Can you? No. But you can see there it's working. So that's it. That's it, ladies and gentlemen. We're all done. So as we can see there, the issue was actually down to a damaged HDMI port. So what had happened is that Andy's cat, I would be making sure that cat was made to pay the bill, but no, in all seriousness, all that happened was that the cat had knocked this PlayStation off the desk with the HDMI plugged in. The machine landed, unfortunately, on its HDMI port, and of course that has damaged the internal header which that port is soldered onto, because of course basically all you've got inside the plastic comb of the HDMI port, that's the only thing that's providing any strength to the pins inside the port. So if you drop and it lands on that port, then essentially the solder joints are what is basically all that's going to take the strain of that drop, and that's going to take the impact. So as we could see, once we actually lifted the old port out, we could actually see that the pin header had actually been damaged through the drop. And actually what had happened was that the impact as such had actually fractured the internals of the board and caused the solder pads to actually lift out, which is quite a nasty, it's quite a nasty bang for that to happen. You really do have to give it a crack. So we ended up running 3 link wires. 5 pads were actually lifted out. 2 of those were ground though, so we weren't too bothered about those. But 3 were signal and did need replacing. We've actually run those, as we showed you, under the scope. We've checked those. We've made sure that they're all insulated nicely now. And this is all ready now to go back together properly. So, as you can see, we get nice output there in 1080p. Machine is set on a nice white light, and we're ready to go, ladies and gentlemen. So thank you very much for watching, and hopefully Andy's enjoyed this video, and hopefully the rest of you have too. If you find this useful, then please feel free to give me a like. Please remember to comment, rate, and of course subscribe to the channel for more of this sort of stuff. We've got some more interesting stuff coming up, so please stay tuned and stay with us. I've been Andy Paul, you've been fantastic, thank you very much, and I will see you on the next vid. So for me, it's bye bye for now.